Okay, the record has started. We can start now.
Hello everyone, welcome to our channel. My name is Harshada and these are my group members. Today we are driving into an exciting machine learning and text mining project where we analyzed PubMed research abstract to clarify the top 10 most common cancer in the world. So let's get into it.
Okay, so first off, I will be explaining about how we obtain the dataset. Uh, we 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 use the link that was sent in the Tron class, which there are two links. On the first one is the WCRF website, which will be linked here, and then we also use the PubMed to download all the top 10 cancers. So in this case, it will be the trachea, bronchus, lung, breast, colorectum, etc. until number 10. So first we collect the data sets from PubMed, and then once we download them all, we had to create a program that can merge all the CSV files into one because all the CSV files is too much to handle to upload. So we have to upload it at one at a time. So we have to upload it so that we can do the upload for the merge files. Can move on to the next. So this was the program. We asked ChatGPT to create us a program on how to merge all the CSV files, and then we came up with this. After that, so we uploaded the files one by one, the top 10, and then we will get a file named merge PubMed cancer dataset.csv. Can move on to the next one. So on the very first one, we first mount it into a Google Drive because it will be very big for us just to upload the file on the Google Colab. And then after we mount it, we initialize the path, which will be the My Drive. You can see on the line 14, the file path is content, drive, My Drive, and then just the name of the merge file. Can move on to the next. So after that, we create a display for the distribution of the articles. And then here you can see all the articles that we have downloaded before become merged into one and then got read in the Google Colab environment. We can move on to the next. Here we are just pre-processing the data and then we analyze all the stop words and everything that will make our data looks unclean. And the one that we need here is the abstract and also the cancer type. Can move on to the next one. Zefania, you can explain the next one.
Okay, so for the fourth part block, there's still function, which is the factorizer and the classifiers. The factorizer, it is as in the assignment, which is the ATF, IDF, and TF-IDF. And then for the classifiers, we decided to use three classifiers, which is logistic regression, net bias, and linear SQL. And then we will show store the results of the previous classifier, the previous block. Then it will also train those three classifiers. And then if it's already done, it will store the results of that training model. And then it will also create a confusion matrix for that three classifiers. And then in our last plot block, we will print the results of the classification. We'll show the accuracy, the F1 accuracy, and sorry. This is the result of our confusion matrix. It show all confusion metrics for the TF, IDF, and both TF, IDF. This is for the classifier performance. So we have tried creating the code 2 times. In our first trial, we used a smaller data set, and as a result, we get a higher training time, get a faster training time, but we get a lower accuracy. As you can see here, the logistic regression, the accuracy is in 20%, for net bias is in 21%, and for linear SVM, it's in 21% too. But as a result, the training time is 2 seconds. Then you proceed to the barcode and a larger data set that you have a higher accuracy, so you have longer times, which is and the accuracy increased for almost like 1.2 times. As you can see here, the accuracy becomes like 27% to 31% to 2%, and so on. So for the accuracy metrics, they show there. There's an score. There's also F1 score. Also, the best performer. The conclusion.
Sorry for barging in. For the conclusion, the best method would be the combining TF-IDF with SPM, as it will provide the highest accuracy. And then for the dataset impact, it utilized a diverse dataset, significantly enhanced the model performance. And then for the future improvement for our project, it will be incorporating additional features and refining algorithms to create a better accuracy and insight generation. And one thing I would say is that a couple reasons that may factor the low accuracy of our project, of our program, is just by how big the data set or how large the data set. Because it looks very unclean even after we merge all of them. For example, in our case, it took nearly 3 hours just to store the result and draw the confusion matrix, just because of the amount of the data set that the program has to get through. Even when everything is done, the accuracy is still fairly low because of all the factors that are mentioned above. Overall, the low accuracy across all models, below 33%, reflects the difficulty of this task, which is that the project emphasized the importance of testing multiple approaches and suggests that more advanced methods like deep learning may be needed for significant performance improvements. I guess that's all for us. Thank you for listening and see you next time.